the first thing you should notice on this page is that the first 6 or so questions look exactly like what we did on the notes from last class. So last class we went through evaluating each and write the exact values only. So we did questions that look like this. We're doing the exact same process, but we're doing it for the 3 questions that are on this page. So it's literally the same process, we're just doing different questions. So before I do any of these questions at the top, I'm going to go ahead and rewrite my table. And hopefully you guys remember the table I'm talking about is your trig table. It looks like this. So we're going to go ahead and at the bottom we're going to write this out, including tangent. So 0, pi over 6, pi over 4, all the way to pi over 2. And we're going to write for sine, cosine, and tangent. So remember, sine is your y values, cosine is your x values. I'll probably put those somewhere so that way you have it. And then sine counts up while cosine counts down. I'm going to square root and divide them all. And then for tangent, Valerie S. What are the tangents for the bottom? And if you need to look back at the other page, you can. What are the tangents? Okay, 0 for the first one. What's the next one? Okay, next. Next. And last. Good job. So with this unit circle table that we just made, I want you guys to answer the first 3 questions at the top of the page. Right underneath the review, evaluate each expression, I want you to solve questions 1, 2, and 3. I'm going to give you a couple minutes head start. Go ahead and solve questions 1, 2, and 3. All right, so I'm going to start by looking at question number 1. If you're still working, you're fine. I'm just going to start working through it a bit. So for question number 1, I'm going to go ahead and draw out, there's 2 different angles that I'm looking at, which are pi over 3 and pi over 4. So pi over 3 is in quadrant 1, and pi over 4 is also in quadrant 1. So I need to take the pi over 3 and pi over 4 representation or value from this chart to find my answer in just a second. So before I do that, let me rewrite what secant squared pi over 3 is. This is the same as 1 over cosine of pi over 3, and this is cosine squared of pi over 3, minus tangent squared of pi over 4. So I just need to look at my chart. So first thing I need to find is what pi over 3 is. So if I scroll down and I look at cosine of pi over 3, so cosine pi over 3, that's going to be the square root of 1 over 2, which is the same thing as 1 over 1/2, and we're going to square that. Minus tangent of pi over 4, I'm going to take whatever that is and square it. So down here, luckily I wrote my tangent. Tangent of pi over 4 is going to give you a positive 1. So down here, we're just going to put in a positive 1. That's the pre-cal part. The rest of this is just algebra 1. So all I need to do from here is I'm going to square the entire 1/2. So this is 1 over 1/4 minus 1. Hopefully you remember we're going to keep, change, and flip this fraction. So keep the numerator the same, change the division into multiplication, and flip your denominator. This is going to simplify to 1 times 4, which is 4 over 1. If 4 over 1 is your fraction, can you just write that as 4 instead? Okay, cool, because I didn't want to put that over 1. And then minus 1, when you subtract that, you should get 3. This is your answer. Question 2, same process. I'm going to graph out where pi over 6 and 5 pi over 3 are. pi over 6 is somewhere about here. Negative 5 pi over 3, be careful. We'll have negative 3 pi over 3. Valeria, where's 5 pi over 3 if it's negative? What quadrant? Say it again. Yeah, quadrant 1. It's going to go all the way around until it gets into quadrant 1, where negative 5 pi over 3 is, because negative 6 pi over 3 is right here, right at 0. So we went all the way around in a clockwise motion to get to negative 5 pi over 3. Okay, cool. The sine and tangent, I have those on my little chart, so I can actually look at those. So the first thing I'm going to look at is sine of pi over 6, which is 1/2. So I'm going to write that one in now. So this is equal to 1/2. And we're going to multiply it by tangent. So, okay, well, wait. I know it's in the first quadrant, but I need the reference angle that will show up at the top part of my chart. So if I'm looking at this angle that I have, Valeria, what's your reference angle going to be? Not pi over 6. Pi over 3. If you're going from 5 pi over 3 to 6 pi over 3, that's just pi over 3 units. That's going to be the same angle in quadrant 1. So looking at tangent of pi over 3, that's going to be the square root of 3. So we're going to multiply this by the square root of 3. Your answer should have been square root of 3 over 2. Questions or concerns? All right, last one. For question 3, I'm going to graph these out. Pi over 3 is easy. Pi over 3, we just saw that. That's over here. 7 pi over 4, we're going to have to go in a clockwise motion. So where this is negative 4 pi over 4, that's a 4. Negative 7 pi over 4 is going to be just like it was in the last question. It's going to be in quadrant 1. So I'm going to go all the way around to get to this angle. Okay, so if I'm looking at 7 pi over 4, I need my reference angle again. So my reference angle in pi over 4, or excuse me, for negative 7 pi over 4, that's just going to be pi over 4, right? If I'm going to go from 7 pi over 4 to 0, which is the same as negative 8 pi over 4, that's just going over pi over 4 units. So let me rewrite what I have. I need to look up secant and cosecant in my table. So in order to do that, I'm going to write that as 1 over, what's the reciprocal for secant, SEC? Cosine of negative 7 pi over 4. And we're going to subtract it from 6 times 1 over sine of pi over 3. So Jenny, look at your table. I don't want to have to keep moving my page back and forth. What's cosine of reference angle pi over 4? Say it again. 1 over square root of 3 over 2. Looks good. And we're going to subtract that from 6 times 1 over sine. And what's sine of pi over 3? Square root 3 over 2? Like that? You gave me these two. Is that what I'm supposed to have? Eurydia, why are you shaking your head? What's wrong? Say it again, Jenny. What were you saying? No. What were you saying? Eurydia, what were you telling me? Square root 2 over 2. Jenny, I hope you see that. This is square root 2 over 2. Please be careful. We're going to have to keep, change, flip both of these. So I'm going to put that in parentheses and close it. We'll have 1 over 1 times 2 over the square root of 2 minus 6 times 1 over 1 times 2 over the square root of 3. All right, I'm going to need the back side of my page in order to finish this, so I'm just going to flip this over so I can actually write the rest. So let's go ahead and rewrite this. We had 1 over 1 times 2 over the square root of 2 minus 6 times 1 over 1 times 2 over the square root of 3. Give me a nod or shake. Is this what I had on the front side? Okay, good. All right, so we're going to simplify. This is 2 over the square root of 2 minus 6 times, 1 times 2 is just 2 over the square root of 3. I can multiply this 6 and 1, or 2, because this 6 is over 1. I can just multiply this fraction straight across. If I was to simplify this any further, Jacqueline, what would I need to do? Okay. So square root of 2, square root of 2, square root of 3, square root of 3. So this is going to give me 2 square root 2 over 2 minus 12 square root 3 over 3. Jacqueline, can I simplify anything else here, or am I done? The 2's can cancel completely. Anything else? These 3's? 12 and 3, good. So this will give me 4 divided by 3 is just 4. Or excuse me, 12 divided by 3 is 4. So my final answer is going to be the square root of 2 minus 4 square root of 3. Is there any denominator for this? And the last question that I have really quick is, can I add or subtract both of these numbers, the 2 and the 3? No, I can't. Yes, ma'am. Mm-hmm.
Right.
Okay, so our answer for this is square root of 2 minus 4 square root of 3. I can't do anything else. The square root of 2 and the square root of 3 are done. I can't change it anymore. So on the front side of the page, examples 1 through 3 here, well, actually I can rewrite my answer. Let me put my final answer, which is the square root of 2 minus 4 square root of 3, just to have it on the front side so I can see it. That's your answer for question 3, which is this guy. For questions 1, 2, and 3 here, I'm not going to worry about them. Those are extra practice. There's methods to my madness. Let's go ahead and look at the last page. Like I said, there's methods to my madness. We're going to look at a couple questions here. I want to look at questions 1, 2, and 6. So questions 1, 2, and 6. If you remember, Melissa asked me a little while ago, what about memorizing the same table that we had on the front page, but with degrees? Well, you really won't need to, because you already know the degrees for this. Pi over 6 is 30, pi over 4 is 45, pi over 3 is 60, and pi over 2 is 90 degrees. We already know these. But instead of trying to memorize more stuff, let's make these problems easier. So for these questions, I don't want you to think, oh, wait, I need to convert, and then I need to do all these other, no. Only thing I want you to do is to convert to radians. Convert this into radians for this page. Make your angle measure into radians. Make your life easier. So before we do anything, at the bottom of the page, we're going to recreate the exact same chart that we had on the first page. Y'all know me. I'm going to have you recreating that chart in your sleep. So at the bottom of the page, I'm about to move it down, and we're going to create that exact same chart, just like you did on the first page. We're just recreating that exact same chart, because when we start solving these questions, we're going to have the same kind of process that we just did on the front. So far, we've been dealing predominantly with degrees, or excuse me, with radians. Now I'm going to show you guys same process, but we're just going to do it with degrees now. Either way, we're still going to convert these degrees into radians in a second. If you are done and you want to start question number 1, cool, go ahead. I'm going to give people who are still writing the chart down a little bit more time before I start doing it. So there's 3 steps to this for each question. When I said to convert it into radians, what's the conversion for that? 180 equals to how many? Pi. So you have pi radians. So that's the conversion that we're going to need to use. So the first thing that I need to do first is I need to convert. So if I'm going to convert this degree into radians, we're going to do 240 degrees, and we're going to multiply it by pi over 180. I don't like you guys memorizing too many things. It hurts your brain. We're going to do 240 pi over 180. Okay, I know for sure the zeros can cancel because I can divide them both by 10. Then I'll have 24 pi over 18. 24 and 18, I know they're divisible by 2, Are they both divisible by 6? What's 6 divided by 24? 4. And then what's 18 divided by 6? 3. So this is the same thing as tangent of 4 pi over 3, which we've been doing pretty much for the past several days. So my second step in this process is to figure out where is 4 pi over 3 in your unit circle. So where is it? So if I look at my unit circle, I have 0, we have 3 pi over 3, and then we'll have 4 pi over 3. Here is 4 pi over 3. In quadrant 3, what trig function is positive? Tangent. Tangent. So especially since I'm finding tangent of 4 pi over 3, my answer for sure should be positive. So my answer is going to be a positive. Let me see. I'm going to write that out. Tangent is positive. Let's go ahead and figure out where your reference angle is going to be. So the reference angle at 4 pi over 3 is just pi over 3. So let me figure out what that answer is going to be up here at the top. So if I scroll back down, tangent of pi over 3 is going to give me square root of 3. So my answer is just the square root of 3. The main thing, we got kind of comfortable on the first page because all of the items were in the first quadrant. So I didn't really check to see what sign they're supposed to be because y'all understand first quadrant, what signs are positive? All of them. That's why I wasn't checking. But make sure you check to see if any of your signs are positive or negative because it will help. Okay, example 2. Oh, this one's nice. It's 45 degrees. What's 45 degrees in radians? Pi over 4. So we don't even have to do the conversion chart. 45 degrees is equal to pi over 4. And especially if you draw out your chart, I'll know that you know that. So step 2, I'm going to graph this out. I know that pi over 4 is in the first quadrant. I know that. So there's really no need for me to rewrite what your angle or anything should be. So my last step is going to be just finding sine of pi over 4 and subtracting it from tangent of pi over 4. So I'm going to look at my chart and I'm going to copy it down. Sine pi over 4 is 2, square root 2 over 2. Tangent of pi over 4 is 1. So we're just going to have square root 2 over 2 minus 1. Okay, so we're going to have square root of 2 over 2 minus 1. This will technically work as my answer, but I know how I might put it on tests and quizzes for your multiple choice section. Find a common denominator for those. What's a good common denominator to use? 2. So we can make that square root of 2 over 2 minus 2 over 2. I would just make this one big fraction because on tests and quizzes, even though this is correct, I'm going to probably write your multiple choice answers like this. So understand, technically both of these are correct, but I just want you to see what both of them might look like on tests and quizzes. Both of these are correct. Try number 6 without me. Try number 6. I know for me, I'm going to need to use the back side of my page because I put my unit circle table at the bottom. So if you want to use the back side of the page, cool. If not, it's okay. We got kind of lazy with the first couple questions. Make sure that your signs, whether they are positive or negative, is correct on your problem. Okay, so I flipped my paper over to the back because I know how I am. I'm going to need the space to actually work this out. So the first thing that I want to do is I want to rewrite this in radians. So 90 degrees is going to be pi over 2 radians. Hopefully y'all know that. 270 is going to give you 3 pi over 2. And then 330 degrees is how many radians? 11 pi over 6. Okay, so I'm going to use the information that I have and I'm going to start trying to figure out where are each of these in the unit circle. So step 2 is drawing out your unit circles. So I'm going to have 3 spaces on the unit circle. Pi over 2 is up here. We have 3 pi over 2, which will be down here. And we have 11 pi over 6, which is in quadrant 4. Okay, so for pi over 2, I'm going to kind of combine this with what I'm doing on step 3. We have 12 cosecant. Cosecant is the same as 1 over sine of 90 degrees, which is pi over 2. You write pi over 2. 1 over pi over 2 plus 1/2 cosine of 3 pi over 2 minus secant is 1 over cosine of 11 pi over 6. Okay, so as I'm looking at these, first thing that I want to determine is what is sine of pi over 2. Okay, sine of pi over 2 is in this quadrant, or technically this axis, the y-axis, and the coordinate up here is 0, 1. I just wrote it on the other page. Is sine x or the y? It's the y. So if you didn't put that on this side of your chart, make sure this is y, this is x. I did it on the very first page. So that's your y, that's your x. So on the back side, I'm looking at my y coordinate, which in this case is 1. So I'm going to plug in that 1 for the denominator. So 12 times 1 over 1, that's my first one. I move this over, plus 1/2 cosine of 3 pi over 2. Okay, here's cosine, or excuse me, 3 pi over 2. What's the coordinate down here? And is cosine the x or the y? X. So I'm going to have to use a 0 this time, which is okay. Minus 1 over cosine of 11 pi over 6. Okay, for 11 pi over 6, we need to do two things. We need to determine what sign is going to be in that quadrant for cosine and what the actual value is supposed to be. So for cosine, in quadrant 4, is cosine positive or negative? Positive. Okay, so I know my answer is going to be a positive down here. That's fine. And then the 11 pi over 6, what's the reference angle? So on the first side of my page, I need cosine of pi over 6, which is square root 3 over 2. That's the value I'm going to use. So square root of 3 over 2. The main reason, or the main thing that you guys will mess up on in the future is not putting your correct sign. This is a positive square root 3 over 2 because it's in quadrant 4. This is your problem, guys. The pre-cal's done. This is just algebra 1. You should have had 12 times 1, which is just 12. 1/2 times 0 is nothing. Minus 1 over 1 times 2 over the square root of 3. This is helping me find the secant, since it's the reciprocal. So I'm going to make that 12 minus 2 over the square root of 3. And what do you think I'm going to make you do here? Rationalize. So this will be square root of 3, square root of 3. So 12 minus 2 square root 3 over 3. What's another way to write that? 36 minus 2 square root 3 over who? 3. How'd you get that? Multiply 12 by 3. If you want to get one big fraction for your answer, again, this will be probably how your multiple choice questions look. Multiply the numerator and denominator here by 3. You're fine. Let me just say one last thing first. Really quick, guys. I know I'm having some of y'all look at this, and y'all are looking at this 36 over 3. Can I cancel these? Can I reduce these and cancel it? Oh, I'm hearing some yes and some no. Who's saying, why are you saying no? It's being subtracted. In this numerator, guys, it's being subtracted. Since it's being subtracted, you can't just cancel these two, the 36 and the 3. You can't just cancel those, no matter how hard you try. If you wanted to cancel something, listen carefully, you would need to factor out the common factor and then cancel it. So for instance, for this one, it can't do it, but if it was able to cancel with this, we'll say 16. I'm totally making this up, guys. 16 minus square root of 3 over 3. This you can cancel because the 3 is being multiplied by all of this. But since this is not, and you can't just cancel, or if you factor out a 2, it's not going to cancel with this denominator. So what I'm going to do is I'm just going to leave it as 36 over 3. Ignore the part that I did at the bottom. And this would be your answer. 36 minus 2 square root 3 over 3. That would be your answer. Okay, so there's one last thing that I want to talk about, and that is going to be on the first page at the bottom. We haven't talked about this one yet, at least not today. This is hopefully going to be very easy for you, so even if I wouldn't have gone through this with you like I'm about to do now, you should still be able to get the answer for questions like example 1A. So I'll probably go through a couple questions with you, and then we'll be done. So the first question we're going to look at is question 1A. So with question 1A, it specifically says finding ratios two different ways. Theta is acute, and sine of theta is 2 square root 7 over 7. You need to find what tangent is. Okay, so the first thing that I need to do is figure out what these two clues they have given me represent. Okay, well, if you have theta is acute, what does acute mean? Acute means that theta has to be in between 90 and 0 degrees. So 0 degrees and 90. Think about that in reference to the unit circle, where all students take calculus. If it's going to be between 0 and 90 degrees, that has to be in the first quadrant. So this needs to be in quadrant 1. So it needs to be here, can't be here, can't be here, can't be here. That also means that if sine of theta is 2 square root 7 over 7, notice that this whole answer is positive. So whatever answer I look for, it's going to need to be in quadrant 1 for sure. Okay, well, let's think about this sine theta, 2 square root 7 over 7. I'm going to write out SOHCAHTOA. And I want you guys to think. Normally, when we have a radical like this, it's usually in the denominator. And especially since both of these have a 7, I think what happened is they rationalized this denominator. So what that rationalize means is I actually need to rewrite it in its original form before I graph this out on my unit circle. So sine of theta is actually 2 over the square root of 7. Because if you multiply square root of 7 over square root of 7, you'll get the answer that I have at the top. So cool, this is my answer needs to be in quadrant 1. Since my triangle needs to be in quadrant 1, not my answer. So let me draw this out. Here's my triangle. Here's my theta. And I'm going to have for sine, this is opposite over hypotenuse. So this is opposite over hypotenuse. So opposite is 2 square root of 7. Now I need to think. If I want to try to figure out what tangent of theta is going to be, what does that mean in reference to this triangle? Well, you should already know, like I wrote at the top, that tangent is going to be opposite over adjacent. That's your tangent. So I need to figure out first, since my triangle is in quadrant 1, what is my answer going to be? Is it going to be a positive or a negative? Well, since your triangle is in quadrant 1, tangent of theta is going to be positive. With that in mind, I can now use this triangle to try to figure out what tangent's going to be. But in order to do that, I need to know what this adjacent side is. So to find this adjacent side, I'm going to label this as A. We're going to have to do Pythagorean theorem. So A we'll say is A, B we'll say is 2, and C is a square root of 7, which we're going to square. So I'm going to go ahead and simplify. A squared plus 4 is going to equal 7 because the square root of something that's already being squared, those two signs cancel. I'm going to subtract 4 on each side, so this will give me 3. And then I'll square root each side. So A would equal the square root of 3. Especially since this is all in quadrant 1, I'm not going to worry about the negative answer here. So I'm just going to write A is the square root of 3. With that in mind now, I can actually write what tangent of theta is. This is opposite, which is 2, over the adjacent, which is now the square root of 3. Y'all already know, on your tests and quizzes, I will expect you to rationalize. So let's go ahead and rationalize this by multiplying by the square root of 3 in your denominator and numerator. So tangent of theta is going to equal 2 square root 3 over 3. That's your answer. Let's go ahead and look at the next page. On the next page, we're going to let's look at letter C. Letter C is nice. Let's have some fun with this. So for letter C, first thing we want to do is read the information that we have to see if we need to change anything or what this is going to look like. So if theta is greater than pi, okay, don't put 3.14. We already established this since we began doing trig. Pi is the same thing as 180 degrees. Whoops, let me put greater than. Pi is greater than, or excuse me, let's try this again. Theta is greater than 180 degrees. Okay, well, let's think about that. In quadrants 1 and 2, that's between 0 and 180. Between 3 and 4, this is where it's greater. So I can't have it in the first two quadrants. This needs to be in quadrant 3 and quadrant 4. Now I need to look at cosine of theta. We talked about this on the last page. We don't have a radical for this fraction, unlike we did for sine, but sine of 2 square root 7, this was positive, which is how I knew it was going to be in quadrant 1. For this one, though, this one's positive. Where is cosine going to be positive? It's It's going to be positive in quadrant 4. So we need to draw this triangle in quadrant 4. That tells you what your signs are going to be. So 12 is the adjacent, 13 is the hypotenuse. That says hypotenuse. So the adjacent side is here, here's theta, and the hypotenuse is 13. Just like we did on the last question, we need to figure out what that number is going to be. So we need to find out what your b value is now. So a squared plus b squared equals c squared. We're going to take 12 squared plus b squared and set it equal to 13 squared. That's 144 plus b squared equals 169. And then I'll subtract 144 on each side. B squared is going to equal 25, which means that b will equal 5. Technically, it's a positive and a negative 5, and normally I say that your length can't be negative, but especially since this is in your unit circle, or excuse me, not just your unit circle, but it's also in a coordinate plane, when it's going 5 like this is actually going down. So my 5 is actually going to be a negative 5. So I'm going to put a negative 5 for that. Technically, when you solve it, you get a positive and negative answer. Since this b is along the vertical side and it's below the origin, we're going to make that 5 negative. The last thing I want to mention is what is your cotangent theta? We're actually talking about the solution now. So for your cotangent of theta, I need to figure out what's my answer going to be. Is it going to be positive or negative? In quadrant 4, tangent and its reciprocal, which is cotangent, is going to be negative. So over here to the side, let me write my answer. Cotangent of theta is going to equal a negative. Okay, let me look at the triangle. Cotangent is the reciprocal for tangent. So if you think of SOHCAHTOA, TOA, that's opposite over adjacent. So tangent is going to be the adjacent, let's write it for tangent, the adjacent over the opposite. So cotangent of theta is going to equal the adjacent side, which is negative 12, over the opposite, which is negative 5. So I keep saying all these negatives, but keep in mind, this is just a negative answer. So we're just putting that 12 over 5. That's why I'm putting that as a negative. It's kind of a reminder. That should be your answer. So right now, I want you guys to try to do letter D completely. So do all of letter D right now. Okay, let's talk about it. Sine of theta is less than 0. Okay, well, if sine of theta is less than 0, let me graph out what I have. All students take calculus. Less than 0 means that it's going to be negative. Sine is only negative in these two quadrants, 3 and 4. So I'm going to cross out this, cross out this. We cannot have our triangle in either of those two quadrants. Tangent of theta is equal to 1. Okay, well, I don't have a fraction here. It needs to be a fraction in order for it to be opposite over adjacent. So I can rewrite this as tangent of theta is equal to 1 over 1. That is the opposite over the adjacent. Okay, well, notice that your tangent is just a 1. It's a positive 1. So my triangle should be in quadrant 3. So let's go ahead and graph this out. This is in quadrant 3. Here's my theta. And I need to figure out, okay, negative. Here's my triangle. Let me put this as 1, 1. And especially since it says that it's going to be negative, keep in mind, as you go to the left, your answers will be negative. As you go down, your answers will be negative. So what we need to find is the hypotenuse. So with my hypotenuse, we're going to do a squared plus b squared equals c squared. A is 1, b is 1, negative 1, and c is just going to be c. So we're going to do 1 plus 1 equals c squared. 2 is going to equal to c squared. So the c value that I'm looking for is the square root of 2. What I need to do now is figure out what secant is going to be. Secant is the reciprocal for cosine. In quadrant 3, secant is going to be negative. So let me write that out. Secant of theta is going to be a negative. Secant is hypotenuse over the adjacent. So hypotenuse over adjacent. Keep writing that D as a J. And we're going to write this as secant of theta is going to equal the hypotenuse, square root of 2, over the adjacent side, which is just that negative 1. I've already put that negative there, so I'm not going to write it again. You want your final answer for secant to be negative. Secant is negative, so you want that negative to be there. If that's too confusing for you, just erase it and put it down here, whoops, with the 1. It's going to give you the exact same answer. All I need to do from here is reduce, so secant of theta is just negative square root of 2. That would be your answer. So the only thing that I want you guys to keep track of, which I mentioned it before, just keep track of what quadrants have what signs, positive or negative. So especially for this one, I made a note. Secant answer needs to be negative. That's what secant of theta is. So secant of theta, my answer is negative. For this question here for cotangent, I said cotangent is supposed to be negative. So that's why I made my answer negative. If it's too much for you to think about with, hey, wait, why did we put the 12 as negative first? Erase it. You can say that the 12 is positive, which it is, and then 5 is negative. Put the negative down here. It's still going to be a negative answer, guys, no matter how you write it. Make sure if you have any questions that you ask me. Other than that, you have extra practice. All of the questions on this page are extra practice.